Okay, welcome to your notes on section 1.2. We're going to discuss functions and their properties. And as you can see, there's a lot of vocabulary in this section. So you're going to want to make sure you have a good grasp of the words in this section so that you understand what we're talking about and that we're on the same page and speaking the same language. So we're going to start in the notes by discussing functions and being able to determine whether a set of numbers or a graph is a function using the vertical line test, or the fact that the x values cannot repeat, and also talk about how to find the domain of a function, whether we're talking about a set of numbers or an equation or a graph. Okay, so here on example 1, we're going to basically state the domain and range of each relation, and then tell whether or not that relation is a function. So for letters A and B, we have what's called a set of ordered pairs, a relation, and so we're going to start by stating the domain of this first one. And remember that the domain is just the set of all first coordinates or x coordinates or input values, however you want to think about it. And so here the set of x coordinates would be -3, 4, and 2. The range is the set of all y values or second coordinates or output values. And so in this case, that would be 0, 2, and -6. Now, to determine if this is a function or not, we need to look only at the x values and see if there are any that repeat. So I have an x value here of -3, of 4, and of 2, and since each of those are different, this is a function. Okay, now in letter B, basically the exact same thing. We're going to find the domain by just writing down the set of x coordinates, and so that's going to be 4. Here I see 4 again, and so I'm not going to write it a second time, but I'm going to go to the next unique value, which would be 9, and then -9. And then the range is the set of the y values, and so that's going to be -2, 2, and -3. Even though I see -3 twice, I'm only going to write it once in my list. Now, when we discuss whether or not this is a function, we look at the domain and see, are there any values in the domain that repeat? And since we see this value of 4 that repeats, we can say confidently that this is not a function. It is a relation because it's a set of ordered pairs, but it is not a function because one of the x values repeats itself. Okay, in letter C, we have the graph of a circle, and so to write the domain of this, we just need to figure out what the smallest x value that this graph touches and what the biggest x value is that it touches. And so if you imagine this to be the origin right here, you can see that this goes as far to the left as -4, and since that circle is actually touching -4, we're going to have a bracket to indicate that -4 is included. And then the circle goes all the way to the right-hand side at +4, and it's also included there. The range is going to be the y values read from bottom to top. So the bottom y value that this circle touches is also -4, and since it is touching -4, that's going to include -4 with a bracket. And the top of the graph stops at +4, and since the graph is actually touching +4, we're going to include it with a bracket. Now, in order to determine if a graph is a function, we need to follow what's called the vertical line test. And so if any vertical line intersects the graph more than one time, that graph is not a function. So you could draw, for example, this vertical line right here, and notice that that vertical line is touching the graph of that circle more than one time, and so therefore this circle, this graph, is not a function. Okay, finally, letter D. Again, if you just recognize that as the origin, we can figure out what the domain of this is. Now, this is not a great picture. Really, what you should see here are arrows indicating that this graph continues both to the left and to the right. And so the domain of this, because it does not stop on the x-axis, is going to be from -infinity to infinity. That's how we would write that in interval notation. Obviously, you could write it different ways, whether you're talking about set builder notation or inequality notation, but in pre-calculus, we're going to primarily discuss things in interval notation. Now, for the range, this is read from bottom to top, and because these arrows point all the way down, the beginning of our range is going to be at negative infinity, and the top of our range is going to stop right here. And so if we just count that on the graph, that's going to stop at positive 4, and since there is actually a point on positive 4, that means we are going to include positive 4 in our range. Now, the next question we need to ask is this a function? If it is, that means it passes the vertical line test, meaning there's no vertical line that we can draw that will intersect this graph more than once. And I would challenge you to try and draw a vertical line that crosses this graph more than once. You will not be able to do it, and therefore this graph is the graph of a function. Okay, now when we want to find the domain of a function given its equation, there are 3 restrictions that we're going to have to take care of and make sure that we're aware of. So for many of the functions that we're going to discuss in this class, the domain is all real numbers. But there are 3 of the functions that do have restrictions, which means that their domain is not going to be all real numbers. So the first of those is the square root function. We cannot take the square root of a negative, and so therefore we're going to have to see anytime we have a radical and make sure that what's underneath the radical is strictly positive or greater than 0. And it can equal to 0. We can take the square root of 0. It's just that we cannot have a negative. So for that first case, we need to check, is the radicand, which is the thing inside the square root, it has to be greater than or equal to 0. For the second restriction, we cannot divide by 0. So that means if we have a fraction and there's a variable in the denominator, that variable expression cannot equal to 0. So for the second one, anytime we have a denominator, we are going to have to set that not equal to 0 to check for domain restrictions. And then thirdly, we cannot take the log of a negative number, and we cannot take the log of 0. So that means when we have a logarithm, any type of logarithm, whether it's a natural log or a common log or any other sort of logarithm, we cannot take the log of a negative or 0. So that means we're going to have to take the argument, which is what we call the piece that's inside the parentheses, and it's going to have to be strictly greater than 0. So these are the 3 restrictions that we're on the lookout for. Otherwise, if we don't have any of these restrictions, we say that the domain is all real numbers or negative infinity to infinity. Okay, so letter A, we have y equals log of x plus 4, and so I see that that is going to fit into my category of having a logarithm, which means I need to check that the argument is greater than 0. So in this particular case, the argument is x plus 4. I put that greater than 0 and solve for x, which means that x is going to be greater than negative 4, and I just need to write that in interval notation. So if you want to draw yourself a little number line just to help you, you've got negative 4. That's going to be open. We want all of the x values that are greater than negative 4. And so in interval notation, my domain is going to be open negative 4, since we cannot include negative 4, all the way until infinity. Okay, letter B, which of the 3 restrictions are we going to have? Do we have a square root? No. Do we have a logarithm? No, but we do have a denominator. And for the denominator, that means that we cannot have, and that's supposed to be pointing to number 2 there, we cannot have a denominator that's equal to 0. So we've got x plus 3 is equal to 0. And so that means that x cannot equal to negative 3. Now, what does that look like in interval notation? Here's an easy way to think about it. We have the entire number line except for negative 3. So if you take the entire number line and then you just erase and don't include negative 3, then what do we have? Well, we have this entire piece, which is from negative infinity until negative 3, but not including negative 3. And we have this entire piece, which is going to be not including negative 3 until infinity. And then finally, letter C, this is your challenge problem. Notice that we have two restrictions going on in one function. We have a square root in the numerator, and we have a denominator. And the first thing we need to do is we need to factor that denominator. So square root of x plus 2 is going to go in the numerator, and in the denominator, we need factors of negative 12 that will add to negative 1, and so that's going to be x minus 4 and x plus 3. Okay, so we have the following restrictions. In the numerator, we have a radicand, and so that's going to be pointing up to this first restriction. We need that radicand to be greater than or equal to 0. So x plus 2 needs to be greater than or equal to 0, which means that x has got to be greater than or equal to negative 2. So I'm going to have negative 2 here. It's going to be included because of the equal bar. And we're going to have everything to the right of negative 2. Now, that does not take care of our denominator. In the denominator, we have that x minus 4 cannot equal to 0, which means that x cannot equal to 4. So we're going to take our eraser now and erase right around where positive 4 would be, and that's going to be not included. And we're also going to have to set this second factor, this x plus 3, equal to 0 as well to see what that restriction is. And so if x plus 3 cannot equal to 0, that means x cannot equal to negative 3. But notice, x wasn't going to be able to be negative 3 anyways because of this restriction right here. So that restriction sort of gets superseded, if you will, by the radicand restriction that we had earlier. Okay, so what is our domain going to be? It's going to start at negative 2 and be included because of the closed circle that we have here. It's going to have to stop at 4 and not include 4. And then you can pick back up at 4 but not include it and go all the way to infinity. And that corresponds to this piece, whereas this negative 2 to 4 corresponds to that piece on your number line.